Hi dear students, let us welcome back to mathematics online class. In a previous video, we have taken that what is a function, what are the types of the function, and based on the types of the function, several examples are solved. Once again, recall what is a function. Let A and B are the any two non-empty set. Then F is a relation. Relation is subset of the Cartesian product. This relation is said to be a function. When it is said to be a function, whenever or if every element of the set A has a one and only one image of the set B, then this relation becomes a function. Next, types of the function. One function or injective. What is a one? Different element of the different images. Different element of the first set A set has the different images of the set B is said to be a one function or an injective function. Next, onto function or a surjective function. What is an onto function or a surjective function? Every element of the coordinate set has at least one pre-image on the set A is said to be a onto function or surjective function. And bijective function. What is a bijective function? A function which is both one as well as onto is said to be a bijective function. Based on that, several examples will be below solved. Yes, let us continue. A few more examples are there. Next example is, if f is a function from R into R is defined by f of x is equal to sin x. Verify that this f is 1 in the domain 0 is less than or equal to x is less than or equal to y. Usually, earlierly, a given function is defined from R into R defined by the exterior. Whole domain set is whole real number we have to consider. Obviously, sin function is also defined for all the real number. But range, what is the range of the sin function? Lies in between -1 to +1. Just for a convenience purpose, I just taken a graph of the sin function. This is a graph of the sin function. Here it is a 0, here is a pi by 2 and pi, 3 pi by 2 and it is a 2 pi. Similarly, negative side minus pi by 2, minus pi and so on like that. We can observe that a sin function is lies in between -1 to +1. Sin is lies also in between -1 to +1 is that. Okay. So sin function is also between -1 to +1. I need to find that a given function is verified. We need to verify that it is a one function from where to where? From the 0 to pi, 0 to 180 degree. A given function is a one or not a one. We are required to verify. Observe that here there are two different values of x. There is the same y value. For two different x value, there is a same y value is that. So therefore we can easily conclude that it is not a one algorithm. We know that algorithm means a general process. We know that. What is the general process to show that or checking the one? Take a two different element x1 x2 belong to the domain set and consider f of x1 is equal to f of x2. Simplifying, if you got x1 is equal to x2, then we can say that f is 1. If x1 is not equal to x2, then we can say that f is not 1. Same process I just consider from the diagram. And one more thing, whenever the graph of the given function is given, whenever a graph of the given function is given, in that case, whenever graph of the given function is given, we just draw one parallel line parallel to the x-axis. Draw the line which is parallel to the x-axis. Just for understanding purpose, short hint is that to verify or to determine whether it is a 1 or not 2. If I draw the parallel to the x-axis one line, that line, if it intersect more than 1 points, the parallel line which is parallel to the x-axis, a line is intersect the graph of the function more than 1 points, then it is not a 1. Why it is nothing but at the two different values there is a same y value. At the two different x value there is a same range is there. So same pre-image is there. That's why. So we can say that it is not a 1. For your convenience, I need to check the 1. How to check the 1? For 1, I need to consider two elements. What are the two elements I just consider? Means for example, pi by 3. What is the pi by 3? Degree measure 6 degree. And also I just write the 2 pi by 3 are belong to the domain set. What is the domain set? Here domain is a closed interval 0 to pi is 0 to 180. Obviously defined for all real number, but we need to verify that. We need to determine whether the given function is 1 or not in this interval, so that it is belong to this interval. It is a 60 degree, it is a 120 degree. So consider f of pi by 3 is equal to f of 2 pi by 3. Is for these two different number, image is same or different? Check it. What is the sign of 60 and what is the sign of 2 pi by 3? Sign of 60 and sign of 120 have the same. 120 is not a standard angle, but we can get it. How? 180 minus 60. Sin of 180 minus theta is sin theta. Sin 60 is equal to sin 60. That will get the root 3 by 2 as well as the root 3 by 2. Both values gives the root 3 by 2. For a two different number, there is a same image is there. But is, can we say that pi by 3 is equal to the 2 pi by 3? 60 is not equal to the 120 degree. Pi by 3 is not equal to the 2 pi by 3. We got x1 is not equal to the x2. Therefore, we can conclude that f is 1 1 or not 1 1. F is not 1 1. That's all. This is how we have to check the value. Are you clear about this one? It is oscillating. So just remember the point, shortcut point. Very helpful, but according to this condition in a theory part we cannot say that, but mathematically we have to prove it. So in the competitive exam you can use this trick to decide that whether it is a 1 1 or not 1 1. So we have verified that a given function is not 1 1 in the interval, or given function is not 1 1 in the whole domain set. So this is the one more important problem. Either they might have asked 1 marks or a 2 marks question. Yes, very important type of the question. Yes, now let's take the next one. Let f is a function from R into R is defined by f is a function from R into R is defined by f of x is equal to x cube plus x. F of x is equal to x cube plus x for all x belongs to R. Show that f is a bijective function for all x belong to the real number R. Then show that f is a bijective function. What is the bijective function? Bijective means the given function is both 1 1 as well as the onto. We have to get it. Yes, prove that a given function is both 1 1 and as well as the onto. So process we know that we just proceed it first of all for 1 1. Okay, so let show that it is a bijective. Obviously 1 1 onto is there, nothing to worry. Take generally x1 and x2 belong to the domain set R. R is the domain set. Next consider, so consider f of x1 is equal to f of x2. Every problem has the same method, same process we have to do. Okay, f of x1 is equal to f of x2. What we just do, then replace the f of x value. What is the f of x value? X cube plus x, but in place of x, x1 is that. What we can write? x1 cube plus x1 is equal to x2 cube plus x2. Now what we can write? We cannot directly cancel it, so that take all the right hand side terms into left hand side. x1 cube minus x2 cube plus x1 minus x2 is equal to right hand side 0. Here it is of the form a cube minus b cube. A cube minus b cube means we can take the x1 minus x2 into x1 square plus x1 x2 plus x2 square plus x1 minus x2 is equal to 0. Here this is one term, this is one term. From these two terms, can I take the x1 minus x2 is a common? Okay, if I take an x1 minus x2 is common, what is left? x1 square plus x1 x2 plus x2 square plus here it is a 1 is equal to 0. Now this is one number, this is one number, open bracket is one number, square bracket is another number. Product of two number is equal to 0. Either any one of the number is 0. So that we can say that either x1 minus x2 is 0 or x1 square plus x1 x2 plus x2 square plus 1 is equal to 0. Okay, provided that what are the x1 x2? x1 x2 are the any real number. On taking the x1 x2 are any real number, is it possible to say that this number is equal to 0? This number is never becomes a 0. Or plus 1 you can shift into right hand side, it becomes a minus 1. Here a square, here a square. So this number, it never becomes a negative value. So it is not becomes to the minus 1. It is not becomes to the minus 1, or else we can say that it is a plus 1 is equal to 0. It never becomes a 0. If this never becomes a 0 means, but they are telling that product is equal to 0, obviously this number must be 0. When this number is equal to 0, whenever x1 is equal to x2. So we just got x1 is equal to x2. So can we conclude that f is a 1 function? Yes, that's all. F is a 1. Mathematically we have proved it. Now go for the onto. Now what is the onto? General process we know that onto. How will you do, or how will you show that it is onto? Consider one element which is from the codomain set. Let for onto consider let any element y is present in the codomain set. From the codomain set, if there is f of x is equal to y, image of x under the f is y. From this replace the x value, f of x value. What is f of x value? X cube plus x is equal to y. Here I have a y value in terms of x. Now I need to get the x value in terms of y. X value in terms of y is nothing but here x cube plus x is a cubic polynomial. Y is any real number and it is a cubic polynomial is that x cube plus x is equal to some any real number. So obviously we know one standard condition. What is the standard condition? We know that means every cubic polynomial has at least one real root in its domain. Every cubic polynomial has at least one real root, which means that whatever the cubic polynomial is just consider, it has at least minimum one real root will be exist. Here also cubic polynomial is that it obviously gives the real number, that we can say that from this statement. So obviously x is present in the domain set. Here what I am just telling that for every cubic polynomial has at least one real root. Every cubic polynomial has at least one real root for whatever the y is belong to the codomain set R. For whatever the y belong to the codomain set R, there exist x belong to the R such that f of x is equal to y, such that f of x is equal to y. From this we can obviously say that it satisfies the condition of onto. Then we can say that f is a onto function. F is a onto function. We have got f is 1 and f is onto. Final conclusion. What is the final conclusion? Hence f is a bijective function. Hence f is a bijective function. That's all. Very important problem for the 2 mark session, or sometimes they will ask the 3 mark session. 1 for proving 1 marks, for proving onto 1 marks, and final conclusion 1 marks, or else this is 1 marks and onto they will give the 2 marks. Either 1 mark, either 2 marks or a 3 marks question they might have asked it. Very important type. Every problem you can observe that whenever you are checking the 1 onto, every problem has the same method. You could only thing change in the function value as well as change in the domain, and the codomain values are changing. Very simple way we can get the answer. Okay, now let's go for the one more problem from your exercise. Parallelly, simultaneously, you just note down the points. All the problem solution is just note down. Pause the video, you just write down it. Okay. Now next example. Let f is a function from n into n is defined by f is a function is from n into n is defined by f of n is equal to n divided by 2 whenever n is even. Whenever n is even, and n plus 1 divided by 2 whenever n is odd. Function is defined. F of n is equal to what? N by 2 if n is even, n plus 1 by 2 if n is odd, for all n belongs to n. State whether the given, for all n belongs to n. State whether the function f is a bisective or not. State whether f is a bisective or not. Check the bisective of the function. Okay, f is a bisective or not, we have to check it. Here function is defined from natural number set to the natural number is there. Okay, function is taking the two different value depending upon the domain value. Whenever n is even number, then that case the function is different value. Whenever n is odd, there in such case a function is taking a different value. So little bit complicated. I just try to get the ray diagram. If I got the ray diagram, because simple function is there, nothing to worry. We can easily get the ray diagram for our convenience purpose, whether it is a 1 1 or not 1 1. Okay, natural numbers are there, both domain and the codomain set. So 9, 10, so on. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on, like that. Try to get the images of each element. If n is 1, n is 1 is nothing but odd natural number or even natural number. 1 is odd natural number. Odd natural number means what is the function value? You have to choose it. N plus 1 divided by 2. Are you sure? Wherever n is there, replace the 1. N is odd, choose this one. 1 plus 1, 2 by 2. 2 by 2 is nothing but 1. Image of 1 is 2. Are you sure about this one? Next, take a n value as 2. Image of 2. 2 is a odd number. Odd number means what is the function value? You have to choose it. N by 2. 2 by 2. 2 by 2 is nothing but what? 1. So image of 2 is also 1. Now try to get remaining elements. Few more elements. Image of 3. 3 is nothing but odd number. Odd is nothing but this is the function value. 3 plus 1, 4. 4 by 2 is 2. Image of 3 is 2. Similarly, image of 4. 4 is even. Even is nothing but n by 2. 4 by 2 is 2. Yes, image of 4 is 2. Similarly, image of 5. 5 plus 1, 6 by 2 is 3. Image of 6, 6 by 2. And image of 7, it becomes a 4. Image of 8 is 4. Yes. Every element of the domain set has the image. Only one and only one image. Obviously, it is a function. F is that. And now, 1 1 we need to verify. Whether it is a 1 1. What is the definition of 1 1? Different element have the different images. Check it. Different element have not a different image, have the same image. Different element 1 and 2 have the same image. Therefore, it is 1 1 or not 1 1. It is not 1 1. That's all. So here counter example which is got it, where it is not a 1 1. Okay, 1 and 2 are the different element, but they have a same image. Therefore, it is not a 1 1. Counter example, we can easily decide that it is not 1 1. What about the onto? Onto means, what is the definition of onto? Every element of the codomain set has at least one pre-image. Do you have that? All the elements of the codomain has at least minimum one pre-image it should have in the domain set. Do you have? Yes, element 1 at least minimum one pre-image. Yes, is that? So obviously, whatever the element we just take from the codomain set has at least one pre-image. Obviously, so onto is that. It is not a 1 1 but a onto. Okay, that one only we need to prove it. Okay, for 1 1. So on ray diagram we just got the conclusion. That one only we need to express it. Okay, for 1 1. Consider the two element. I just consider 1 and 2 belong to the domain set, natural number set. Consider image of 1 is 1. Similarly, image of 2 is also 1. Two different element have the same image. Now from this, do you have those two different element are equal or not equal? Whether 1 is equal to the 2? No, 1 is not equal to the 2. Then x1 is not equal to the x2 manner. So f is not 1 1. F is not 1 1 over. Next, for onto. What is the onto? Choose the any element from the codomain set. It should have at least one pre-image. Here there arises the two cases. Why it arises the two cases means there are function values taking two different value. So that first case, whenever n is a even number. N is a even number means what is the function value? F of x is equal to n divided by 2. Okay. let any element, that I just consider any element y, or n also you can consider any element y belong to the codomain set n. Any element y belong to the codomain set n. So we can say that f of x is equal to y. We have to require to get it now. F of x is equal to y. Replace the f of x. F of x is nothing but here it is a n. F of n is nothing but n by 2. F of x is nothing but n by 2 is equal to y. N by 2 is equal to y, which is called. One second. Here x is there. I just write in terms of x. X by 2 is equal to y. So x is equal to y. Usually what we have to get, y value in terms of x is there, get the x value in terms of y, get the x value in terms of y. Whatever the y value, natural number, whatever the y is a natural number, y is a natural number means it should be y is always a even number. Whenever y is a even number, either n or a y is a even number, is it x present in the domain set or not present? 2 into any even number, even natural number present in the domain set or not present? Obviously present in the domain set n. Present in the domain set n is nothing but it satisfies the condition. Therefore f is a onto function whenever n or y is a even number. Similarly, second case, I just proceed here. Second case, what is the second case? Whenever n is a odd number, in the n is odd number means f of n is equal to, what is the value? N plus 1 divided by 2. In place of n I just consider the y. Okay, so now let any element y belong to the codomain set, y belong to the codomain set, then I need to get f of x is equal to y. What is the f of x? That means given function x plus 1 divided by 2 is equal to y. So y value in terms of x is that, try to get the x value in terms of y. So this will become so 2y and x is equal to 2y minus 1. What is the y value? Y is any odd natural number, y or n. Y is any odd natural number. Y value odd natural means we have to start a y value from 1, 2, 3, so on. So odd is required, particularly 1, 3, 5, 7. Replace it, simplifying, that value x will come. That x is present in the domain set or not present? Yes, obviously it is present in the domain set n. It present in the domain set is nothing but it is satisfied. Therefore f is onto. Therefore f is onto. So f is not 1 1 and in both case f is onto. Therefore final conclusion, hence f is onto but not 1 1. F is onto but not a 1 1 function. That's all. Very simple and important for the 3 mark session. So just remember one problem, how to proceed, how to verify, how to check the 1 1 and the onto. If you remember, if you practice one problem, only thing the function values is changing and domain codomains are changing, we can easily manipulate or you can easily solve the respective problems. Are you sure my point? Just practice it and clearly understand. If you are not understand at the first instance, just repeat the video, will get the point. Clearly observe it. Okay. Okay. Now go to the next example. Here problems are over. Now here particular one note, very important note for the 1 mark session. They will ask it. Let A and B are the two non-empty set. A and B are the any two non-empty set. Different results are there. Generally I am just defining. A and B are the two non-empty set. Suppose if n of A, elements of the set A has a m number of elements, elements of B has a n number of elements. Set A contains a m number of elements and set B contains a n number of elements. Now, in earlierly, if people know that what is the total number of relation? What is the total number of relation? Total number of relation is equal to 2 power n of A into n of B. Are you sure about this one? So, in the same way, total number of function sizes required. What is the total number of functions? Total number of functions from the set A to set B. Total number of functions from the set A to set B. So already you know that from the ray diagram. For example, set A contains 1, 2, 3, 4. and set B contains A, B, C, D. A and B are the two different set is that it is a function. Function means every element has the one image. Element 1, 2, 3 and the 4. Is it a function or not a function? What is the definition of function? Every element of the set A has one and only one image on the set B. Is the condition is satisfied? Yes, obviously it is satisfy the condition. Are you sure my point? In the same way, here first instance this one. Similarly, this is one function. Second case, 1 is related to B, 2 is related to B, 3 is related to B, 4 is related to B. Like that, here how many different function we can write it? In that manner, here we can write the different number of functions. Therefore, total number of functions from the set A to set B is equal to total number of elements in the set B. Total number of elements in the set B whole power total number of elements in the set A. What is the total number of functions from set A to set B? Total number of elements which are present in the set B to the total power total number of elements which are present in the set A. N of B is nothing but N. N of A is nothing but M. This is very important. So, power base is the total number of elements which are present in the set B and index is total number of elements which are present in the set A. N power M. Similarly, next point, total number of 1 functions. Total number of 1 function. What are the total different number of 1 function we can write whenever set A and set B contain M and N number of element respectively. In such case, the total number of 1 function is equal to N of B permutation N of A, which means that N P M. Total number of 1 function is N of B permutation N of A. Already know that Npr formula. What is the Npr formula? N factorial divided by N minus R factorial, provided that R is lies in between 0 to N. R is lies in between 0 to N. Here also M is lies in between 0 to N. Set A contains lies. Set A contains number of elements in the set A is not more than the number of elements which are present in the set B. Like less than that one or equal to the same. Here same element, here it is E, F we can get it, but it should not be only the 3. Suppose A contains 4 and B contains 3, which is not possible to write the 1 function. It should be more than the 4 element. Whatever the number of elements are present in the set A and set B contains the same number of elements or more than that element, then only it is possible, unless which is not possible. This is a formula to find the total number of 1 function. Similarly, total number of functions from the set A to set A itself. From the set A to set A itself, the same formula you can apply it. Set A in place of B also, set A is that N of A power N of A. We can write this value as M power M. This is the total number of 1 function. Similarly, total number of next thing is a bisective function. Total number of bisective function. What is the total number of bisective function? Bisective means both 1 and the onto is given by N of B. That means N factorial, N of B factorial. N of B factorial is nothing but N of B, which is nothing but second set, codomain set, provided that here if N of A is equal to N of B. Only when it is N of A is equal to N of B. This condition is not satisfied, then it is not possible to write. Only when domain set and the codomain set has the equal number of elements, then only this formula is holds good. If not equal is there, then the different result is there. We'll study in the competitive exam. Until that, you just remember these formulas very important. So this, based on this condition, they will ask the 1 marks question. How they will ask the 1 marks question means, for example, suppose N of A contains the 5 elements. N of A contains the 5 elements And what is the total number of 1 function from A to A? What is the total number of 1 function from the set A to set A, they will ask it. So here total number of 1 function from set A to set B, number of elements in the coordinate set permutation, number of elements in the domain set, we can easily write. So n of pi up pi, we can easily write it. So that will give the n factorial, that will the pi factorial. We can use this formula, simplify, we will get the answer. Pause the video, just note down these standard result, and you must and should remember these result, very important for the 1 marks session as well as in the competitive examination. Okay. So this is all about the functions, types of the functions, and particular example we have solved earlier. Now the next point, second exercise is over. Now the next thing is in the chapter relation function is composition of the two functions. Composition of the two functions. Composition of two functions. So composition of the two function. What is meaning of this one? We have to combine the two function. How to combine the two function means, general definition I just consider. Let f is a function from the non-empty set A to non-empty set B, and another function I just consider g is another function from the non-empty set B to non-empty set C. Consider the two different functions f and g in a such a way that f is a function from A into B, domain set is A, codomain set is B. G is a function from B to C. Here whatever f and g is there, here B into C, here codomain set, here it becomes a domain set. In such case, so combination, combining these two functions, how the composition of these two functions, composition of these two f and g is denoted by, f and g is denoted by g circle f. Composition of the f and g is denoted by g circle f, which is a function from, domain set of A into C, which is given by domain set A into C. Here one more thing, we can define by, how to define this function? F of the element A is equal to B. Image of A under the function F is equal to B. Similarly, g of B is equal to C. Image of B under the function g is C. Here it is defined by, g circle f of A is equal to C. G circle f of A is equal to C. This is the definition of the composition of the two functions. Let's take pictorially. Suppose the three sets are there. This is the set A, this is the set B, and this is the set C. Let f is a function. F is a function from A into B, and G is a function from B into C. So already know that f is a function from A into B. Either f of A is equal to B or f of x is equal to y. What is the meaning of this one? Image of A under the function f is B, or image of x under the function f is y. Usually just denote in this way. X is belong to this one, y belong to the codomain set. It is A to B. This is just right. Image of x under the function y. Y is nothing but we can write the f of x. Already know that. In the same way, I am just rewriting this one. How I am just rewriting? Here, observe that. Set A contains element A, set B contains element B, set C contains element C. So A, B, C are the three set, and A, B, C are the any three element. A belong to set A, B belong to set B, and the C belong to the set C. Already know that f of A. What is the f of A? F of A is equal to B. Are you sure? Image of A under the function f is what? B. What is the B value? B value is nothing but, can I write as f of A? B is equal to f of A. Yes. Similarly, image of B under the function G is equal to what? C. C is equal to, but we can write the C is equal to G of B. G of B. What is the B? B is nothing but what? F of A. G is equal to what? F of A. Are you sure about this one? Now this function, what is this function? This is a function G circle F. This is a function is G circle F defined by G circle F. Image of A, image of this element A under the function G circle F is equal to what? Is equal to C. This is exactly the meaning we will get, a composition of the two function. To take the composition of F and G is denoted by G circle F. Image of A under the function G circle F is equal to C. This G circle F is a single function, not two different function. Earlier it is F is a function, G is a function, two different functions were there. But at right now, this is G circle F is a single function. Here observe that domain. Here it is a codomain. For G function it is the domain function. This becomes from the set A to C. This is the domain set is A and codomain set is the C. So this is the exactly the definition of the composition of the two functions we got it. I think you people are clear about the definition of the composition of two function. Are you clear about this one? Okay, I hope it is clear. Now let us take a few example based on this one. If you need, you just write the definition. What is the definition? Let F is a function from A into B. You just note down. Let F is a function from A into B defined by F of A is equal to B, and G is a function from B into C defined by G of B is equal to C. Then the composition of the two functions F and G is denoted by G circle F from A into C is defined by G circle F of A is equal to C. G circle F of A is equal to C. That's all. It is said to be a composition. Just for your convenience purpose, you just take down this diagram. Pause the video. You just note down this diagram. Just write it. We'll get the clear picture about this one. Now let's take a example. What are the example? I just consider example. Find the composition of F circle, or first of all find the G circle F and as well as F circle G. Both are possible provided that F is a function from R into R is defined by F of X is equal to X square. G is a function from R into R is defined by G of X is equal to sin of X. So they have given two functions. What are the two functions they have given? One function is F domain and the codomain are the set of real number to the set of real number defined by F of X is equal to X square. Another function G is from R into R defined by G of X is equal to sin X. Here to write that G circle F is nothing but G circle F. What is the G circle F? This we can write. G circle F is nothing but, can I write in this way? G of F of A. So here any element X. So G of F of X. G circle F of X can be written. G circle F of X can be written. G of F of A. This we can write G of F of A is equal to C. Are you sure about this one? Okay. From the definition. Now replace G as it is. Just replace the inside value. Inside value is nothing but, first of all replace the F of X value. Here F of A value is B. Then G of B value is C. In the same way, F of X value. What is F of X value? X square. Now which is of the form? G of B. Which is of the form? G of B. What is the G of B? G of B is nothing but here is equal to C is that. Okay. G of B is nothing but which is of the manner G of X is equal to sin X. In place of X, X square is there. This we can write it as a sin of X square. This you can write as a sin of X square, angle square. In place of X, you just replace the X square. That's all. Similarly, and F circle G of X. What is F circle G of X? F of G of X. In this case, first of all, replace inside value. What is the inside value? F circle G of X is equal to F of G of X. First of all, replace the G of X value. What is the G of X value? Sin of X. Now, Here f of sin x is there. F of sin x. Already know the f of x is equal to x square. Here f of sin x in place of x sin x. What we can write? X square in place of x sin x. That means whole square. Here we just write the sin x. This we can write as a sin square of x. Are you sure about this one? From this example, we can easily conclude that. Can I say that g circle f of x and f circle g of x both are equal or not equal? These two are not equal. Here we can make a note. What is the note we have to mention is in the composition of the two function, commutative law is may not be whole square, may not be. In some problems it whole square, commutative law is whole square, but in some problem the commutative law does not whole square. So we just make the statement. What is the statement? In the composition of the two function, commutative law may not be whole square. Sometimes it is true, sometimes it is not true. So just take the general case, may not be whole good. Okay. Now let's take a few more example based on the composition of the two functions. Yes. Let f is a function from R into R and g is a function from R into R. Be defined by, both functions are defined by, f of x is 3x plus 5 and g of x is x square plus 2. Earlier definition we know that. What is the definition? F is from A into B and g is from B into C. The first function codomain set, second function domain set must be same. Then only we can write the G circle, composition of F circle G, that we can write G circle F. Similarly, if you write the F circle G means domain of the G function B into C, codomain of this function and the domain of this function must be same. Okay, so both cases satisfy because domain R into R is nothing to worry. So we can consider the G circle F and as well as the F circle G. So first of all, G circle F, they are not given x, consider the x. Now what is the meaning of this one? G of F of x. Just remember this definition. Now we have to replace the inside value. What is the inside value? G of, first of all, F of x value. What is the F of x value? G f of x is nothing but 3x plus 5. F of x is nothing but 3x plus 5 is that. Okay. Which is of the form g of x in place of x. In place of x, what is the value? 3x plus 5. Replace it. What is that? In x square. That means 3x plus 5 whole square plus 2. Wherever x is there, replace this value. Just expand it, simplify. What will get? That is a 9x square plus 25 plus 30 times of x plus 2. This we can write 9x square plus 30x plus 27. This is the required G circle F. Similarly, second case. What is the second case? F circle G of x. What is F circle G? F of G of x. First of all, in this case, we have to write the inside value. Inside value is nothing but G of x value. What is the G of x value? X square plus 2. Now, which is of the form? F of x. Wherever x is there, replace the x square plus 2 in the given function F of x. 3 as it is. In place of x, x square plus 2 plus 5 as it is. Now, what we can write? This we can write 3x square plus 3 to the 6 plus 5. Finally, 3x square plus 6 plus 5. What we can write the 6 plus 5? We can write as the 11. That's all. This is how we have to write the composition of the two function. Are you clear about this one? Hello? Yes. Now, just for a practice purpose, take it. Another example. Find the G circle F and F circle G of the following functions where F is defined from R into R and as well as G is also defined from R into R. Both F and G are defined from real number to real number. In such case, find the G circle F and the F circle G. Very important question for the 2 marks or 3 marks. First one. F of x is equal to mod of x and G of x is equal to mod of 5x minus 2. Yes, try to find the F circle G and G circle F for these two particular examples? Very simple. You can easily solve this one. Find the F circle G and G circle F. I need to find the G circle F. G circle F is nothing but X is not given. Consider this one. Now again this we can write G of F of X. So first of all, which value we have to replace? We have to replace the F of X value. G as it is. What is the F of X? F of X is nothing but mod of X. Wherever X is there, replace the mod X. Wherever X is there, replace the mod X in the G function. G of X is nothing but what? Here X. Here I need X is there. In this place of X, I have to replace the mod. Original this mod as it is, 5 as it is, in place of X, mod X minus 2 as it is. This is the required G circle F. Similarly, and F circle G of X. What is F circle G? F of G of X. What is the F of G of X? F as it is. First replace the G of X. What is the G of X? Mod of 5x minus 2. Okay. And now which is of the form F of X. In place of X, what is the value? Mod of 5x minus 2. In place of X, replace it. In place of X, mod is that. So mod of what we can write? This is the mod of 5x minus 2 mod. Mod is nothing but it is sufficient to write the only the one time modulus sign. Because mod of mod X, which is nothing but sufficient to write only the once mod X. Are you clear about this one? So I think no need to get the confusion. Very simple. Earlier it is founded. For example, here F of X is equal to 3x plus 5 is there. Suppose I need to ask, suppose if I ask the F of 2, what you used to do that F of 2, wherever X is there, replace the 3 as it is, in place of X 2. Are you sure, my man? Instead of a number, here are some function value in terms of X is there. That is the difference. Hello? Very simple. Just observe it. Observation is very important. How the position is changing, which term we are replacing, what is the value I am just keeping as it is. Only the variable X value I am just changing. Only the X value I am changing. So that X value you have to keep very important. Okay. Now in the same way, better take the one more example just for a practice purpose. Very important even in a theory as well as in the competitive exam purpose. F of X is equal to 8x cube and G of X is equal to x power 1 by 3. Yes, try to find it. This problem is frequently asked in the examination for 2 marks. Bada sarti question no kelara. Okay. Yes, find the same. Both F and G function depend from R into R. Find the F circle G and G circle F. Okay. Pause the video, try to solve it. At the end, you just cross verify. First of all, I just try to find the G circle F. That means G circle F of X. G of F of X. First of all, what we need to do? We have to replace the F of X value. G as it is. What is F of X value? F of X is nothing but 8x cube. Which is of the form G of X. In place of X, what is the value? 8x cube is there. Wherever X is there, replace the 8x cube. Here X, that whole power 1 by 3. In place of X, what is the value? 8x cube. Very simple. Now using the laws of indices, simplify. AB power n. What is the AB whole power n? That we can write A power n into B power n. Here also 8 power 1 by 3 x cube whole power 1 by 3. 8 power 1 by 3 is nothing but cube root of 8, that is nothing but 2. X cube whole power n, that means A power m, that power n is equal to A power mn. So x cube 3 get cancelled, which becomes 2x. This is a G circle F is over. Similarly, F circle G of X. What is F circle G? F circle G is equal to F of G of X. What is F as it is? What is G of X? X power 1 by 3. Now which is of the form F of X. Wherever X is there, replace the X power 1 by 3. X is there. Okay, bala careful. 8 as it is. In place of X, X power 1 by 3. whole power 3. Are you sure about this one? Wherever x is there, replace the x power 1 by 3. Here 3 get cancelled. What is left? 8x. So most of the students used to write that here also 2x. So don't get confusion, just compare it, the position where I am just replacing, which value I am just replacing, very clearly observe it, will get the required answer. This is the F circle G, this is the G circle F, very important. Okay, practice these problems, will continue in the next video. Very important point, composition is required because next theorems are there. You have to understand the theorem means you should know the composition of the two functions. Okay, see you in the next video. Thank you.